Hey guys, today we're going to take a look at 6.2, and we have looked at. Trying to move my screen here. We've looked at angles in a coordinate plane, and we've looked at right triangles, and now we're going to put those two ideas together. So what we're going to do is we're going to be looking at right triangles like in a coordinate plane. So again, things are going to look a little differently because we're in a coordinate plane. So for example, let me just get into this. So let's say I've got some point xy just out in space somewhere, okay? If you draw a line from the origin to that point, okay, that's going to be the terminal side of like this angle right here, okay? Initial side, terminal side. So that line, that's going to be our terminal side. If we draw a line straight down to the x-axis, okay, we're always going to draw lines to the x-axis, always. If we draw a line straight down to our x-axis, that is going to be the side that's opposite of our angle. And then the x-axis will always be our initial side of the angle, or the adjacent side of this triangle that we just drew. So look at what we have. I was given a point xy, so we know the length of this side is x. We know the length of this side is y. We could use the Pythagorean theorem to then find the length of this side. We've labeled this r. Think radius of a circle. So like if you turn this into a big circle, this distance right here would be the radius. Okay? So given this triangle, let's take a look at what our 6 trig functions would look like in terms of x, y, and r. So first off, sine. Here's my angle, there's theta. Sine is opposite over the hypotenuse, so y over r. Cosine will be x over r. And then the tangent would be y over x. So if I give you a point out in space, you actually know the tangent of it right away, but we would have to use the Pythagorean theorem to find the radius, and then we'll know, everything about it. Cosecant, secant, and cotangent are just going to be the reciprocals of these. So r over y, r over x, and x over y. Okay? So it's actually pretty straightforward. The one little tricky thing is going to be, now that we're in a coordinate plane, okay, and you could go up, you can go down, you can go left, you can go right, we have to account for negatives, okay? So you've never had a side of a triangle be negative before, but in a coordinate plane, that can happen, and it's going to be important that we notice it if it does happen, okay? So, for example, find the exact value of each of the 6 trig functions of an angle with point xy on the terminal side. Okay, plot the point, draw the angle, and then use the Pythagorean theorem. All right, so 5, negative 12. So we're going to go right and we're going to go down. So I'm going to draw a coordinate plane over here, and think about where this is. If I'm going right and down, this is in quadrant 4. So what I'm going to do is I'm going to kind of zoom in on quadrant 4. I don't need the entire coordinate plane. I just need this. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's the point 5, negative 12. 5, negative 12. Okay? So I'm going to draw a triangle out of this. I'm going to go from the origin. I'm going to go down to the triangle, or to the point, sorry. And then I'm going to go straight up to the x-axis. You always go back to the x-axis. Now, I'm going to label what I know about this. I know that this x side is 5. I'm going to know that this y side is negative 12. Again, that's important that we label that negative there. And then, what would my hypotenuse be? So, Pythagorean theorem, put that in your calculator, 5 squared plus negative 12 squared. Make sure you put parentheses around the negative 12 if you put this into your calculator, and you're going to get 13. All right, and here is my angle. Remember, my angle is always between the x-axis and the terminal side, or the hypotenuse. Okay? All right, here we go. Sine is going to be negative 12 over 13. Cosine is going to be 5 over 13. And the tangent is going to be negative 12 over 5. All right, and then once we know those, we know the cosecant. It's also, now, if I'm going to take this fraction and flip it, it's still going to be negative. Negative 13/12. The negative sign, you can attach it to the 12, so I could have put this 13 over negative 12. But if you have a part of a fraction that's negative, the whole fraction is negative. So you can also just put the negative out front. The secant of theta will be 13 over 5, and the cotangent is going to be 5 over negative 12, or negative 5/12. That's it. Okay, so given a point in space, negative 1, negative 2, so think about that. So I'm going left and I'm going down. So this is in quadrant 3. So again, I'm going to zoom in on quadrant 3. I'm going to go negative 1, and then I'm going to go down to, there's the point. This is a point. Okay, when you just saw me draw my x and y axis, I went left 1, and then I went down 2 to kind of create these points. I have a lot of students who will then connect those two together. That's not a thing. This is a point out in the coordinate system. Draw the point, plot the point, negative 1, negative 2. And then we're going to go from the origin to that point, and then I'm going to go up to the x-axis. There's my angle. Okay, it's like those reference angles we drew. It's always close to the nearest x-axis and to where your angle is. I'm going to label, this is negative 1, this is negative 2. I'm going to do the Pythagorean theorem. Well, that squared is 1, that squared is 4, so that's going to be radical 5. Radical 5. And that's it. I have to write it like that. Because now I'm going to write these ratios. So I need that radical. I can't write it as a decimal. Alright, so what do I know? Sine, cosine, and tangent. Alright, so sine is opposite over the hypotenuse. So negative 2 over radical 5. Now, if you want to write that, and then like negative 2 over radical 5, and then rationalize it, negative 2 radical 5 over 5, that is the correct answer. Okay, same with cosine. Cosine is going to be the adjacent. So negative 1 over radical 5. Which would be negative, well, it'd be negative 1 radical 5 over 5. Now, I don't need to write the negative 1. I could just write this as negative radical 5 over 5, and that'd be fine. Some of you may be able to do this in your head, and so you may just write these down immediately. But remember, when I go to write the reciprocals, I would actually like to have this. This is the one I want to flip. Okay, and it'll rationalize itself for me. What's the tangent? Tangent is going to be the opposite over the adjacent. So I've got negative 2 over negative 1, which means those negatives are going to cancel out, and I'm just going to get 2 over 1, or just plain 2. Okay, so notice what happened here. The sign was negative because we had a negative sign. Your hypotenuse is never negative. Okay, that is the length from the origin out to that point. You will never, ever, ever have a negative here. It's only x's and y's that have like direction where they could be negative. Again, think of this as like the radius of a circle. You wouldn't have a negative radius. All right. But notice what happened. The sine and the cosine were both negative. The tangent is actually positive because those two negatives canceled out. Okay? Cosecant, secant, and cotangent. So I'm going to take those and I'm going to flip them. So again, radical 5 over negative 2. Radical 5 over negative 2. That's the one you want to flip. Radical 5 over negative 1. Or just plain negative radical 5. However you want to write that. And then the cotangent is going to be 1 over 2. Okay? All right. All right, so for example C and D, why don't you try that? So pause the video because I'm going to work them out, and then you can check to see that you did them right. So C and D, both of these, pay attention to, like, again, what quadrant that point is in, and then draw your triangle based off of that, and then label all your functions. All right, pause the video. All right, so check your answers with mine. So for example C, that triangle is in quadrant 2. The point's in quadrant 2, so everything's in quadrant 2. Again, notice that that means that the x side is going to be negative, the y is positive. I found my hypotenuse to be 5. Again, my angle is between the terminal side of the angle and the x-axis, and then I can relate my opposite, adjacent, and things like that to draw my to write my functions. So here are my functions. Again, notice that the sine is positive, the cosine and the tangent should both be negative. Okay, and again, that's because the cosine and the tangent involve that adjacent side, which was negative, but the sine doesn't. Okay, the sine is just the y and the hypotenuse, and both of those are positive, so the sine is positive. Okay, for D, D was in quadrant 1, so everything's positive, but I did give you a weird hypotenuse. Okay, so this was a 5, this is a 4. 5 squared is 25, that's 16, and when you add those together, you get 41. So radical 41 is the length of my hypotenuse. I had to write it that way, and so I had some work to do as far as rationalizing. So 4 radical 41 over 41, that's my sine. 5 radical 41 over 41, that's my cosine. And then just 4/5, that was my tangent value. Okay? So again, you'll notice that as you're doing these, a lot of times some of the functions end up positive, some of the functions end up negative, and it has to do with where you are in the coordinate plane and what's positive and what's negative to create those functions, which is what we're going to talk about next.